In today's class, we want to talk about how to find the product of two matrices. So, the product of a matrix A and a matrix B can only be calculated if the number of rows of A is the same as the number of columns of B and vice versa. So, what that basically means is that before I can find the product of two matrices, I must first consider the number of rows. That means that the number of rows of A must be equal to the number of columns of B. It's very, very important. And as well, the number of columns of A must be equal to the number of rows of B. So let's give an example. That means that if I have a 2 by 3 matrix as a matrix A, then I can only multiply a 2 by 3 matrix by a 3 by 2 matrix. I can only multiply a 2 by 3 by a 3 by 2 matrix because the number of rows here is number of rows, it must be equal to the number of columns here. So the number of columns here must be equal to the what? Number of rows. And recall that is always written, the order of a matrix written by as row times column. So the number of row here is equal to the number of column here. The number of column here is equal to what? Number of row here. As well, we can as well find the product of two square matrices that are of the same order. So what I mean by that is 2 by 2 matrix can multiply a 2 by 2 matrix because the row here is equals to the column on this end and the column here is equals to the row on this end. So I can find the product of 2 by 2 times 2 by 2, 3 by 3 times 3 by 3. Then I can find 4 by 3 multiplied by what? 3 by 4. So I can find 3 by 7 multiplied by 7 by 3. So is in that proportion before I can find the product of two matrices. And I need us to note something, that the product of matrix A is not equals to matrix A and B is not equals to B times A. So AB, if you find the value of AB is not equals to what? BA. How do we solve this? So we are asked to show that AB, the product of A and B, is not equals to the product of B and A. So let's quickly find AB first. So AB, we can open a very big bracket. Now, how do we find the product of two matrices? Very simple. So you go ahead to say that, go to the first matrix, the matrix A that you are starting with, because the product that you are looking for is AB. So it's important that you start from A. So you go there, pick the first row of A. So the first row of A is 4, 4 and minus 1. You pick the first row of A, you multiply it by the individual columns of B. So what we mean by that is multiplied by the first column, 5 and 0. You pick that same row, 4 and minus 1, multiplied by the second column, that's what? Minus 3 and 2. So you are done for the first part. Then you go back to row 2 of matrix A. You pick row 2, you have 3 and 7. You are multiplying by the first column of B, 5 and 0. Then you pick the same row, 3 and 7, multiply by what? Minus 3 and 2. So we would have this. What we have to do next is that we multiply this by this, that is the first one by the first one, second one by the first one, second one by the second, first, second, then sum what we have together. Then we have the matrix AB. So what we would have from here, we are going to have AB is equals, so we are going to have 4 times 5 will give us what? 20. Minus 1 times 0 would have minus 0. So we would have 4 times minus 3 would have minus 12. Minus 1 times 2 will give us what? Minus 2. Then 3 times 5 is 15. 7 times 0 is 0. So that will be plus 0. So we have 3 times this is minus 9. 7 times this is what? Plus 14. So finally, we are going to have that matrix AB that we are asked to find is given by 20 minus this is 20, minus 12 minus 2 is minus 14. 15 plus 0 is 15, minus 9 plus this will give us plus 5. So matrix AB gave us 20 minus 14, 15, and 5 in our answer. So let's try to find matrix BA. In order to find BA this time around, so we have to multiply B by A, not AB. So we'll be multiplying the row of B by the columns of A. So we have the answer for A to AB here so that we can compare when we are done finding the product of B and A. So to find BA this time around, you'll be multiplying the row of B. So the first row of B is 5 and minus 3. You are multiplying by this column here. You have 4 and 3. Then we have that same process. You have 5 and minus 3 multiplied by the last column there. That's minus 1 and 7. So pick the second row of B. You have 0 and 2 multiplied by the first column of A, 4 and 3. Then you have what? 0 and 2 multiplied by the second column, minus 1 and 7. So what we are going to have is you're going to multiply this by this, minus 3 times this, then 5 times this. Is that okay? So we are going to have BA will give us 5 times 4 is 20. You are going to have 20 minus 3 times this will give us minus 9. So that's 20 minus 9, because 5 times 4 is 20, minus 3 times this minus 9. 5 times this is minus 5. Then minus this time, this is minus 21. So we have 0 times 4 is 0. 2 times 3, 6, that's plus 6, right? Then 0 times this is 0. 2 times 7 is 14. So if we compare our answer together, the value of AB will give us 20 minus 9 is 11, minus 5 minus 21 give us minus 26. Then 0 plus 6 is 6, 0 plus 14 is 14. So therefore, if we compare the answer of BA with AB, you see that they are not equal. From our observation, we could conclude that matrix or the product of AB is not equal to the product of BA, no matter the order of the matrix.